A mysterious interstellar object was spotted by astronomers last week, and it could be among the most ancient comets ever observed. It marks only the third instance where we've detected an object originating from beyond our solar system, establishing a benchmark for identifying such celestial visitors. It all began with a quiet but intense moment of revelation when renowned theoretical physicist Michio Kaku stood before a global audience and unveiled a finding that sent ripples through both the scientific community and the public imagination. A new object, previously unknown and entirely unexpected, had entered our solar system. Unlike a typical comet or asteroid adhering to the familiar rules of celestial mechanics, this was something entirely different. The announcement marked a pivotal chapter in the ongoing exploration of the cosmos, raising fundamental questions about interstellar travel, cosmic anomalies, and the very fabric of our understanding of space. Before delving deeper, please engage with this content by liking and subscribing for more updates. The object was first detected by an array of deep space telescopes, particularly one stationed in high Earth orbit, whose instruments captured a peculiar reading in the Kuiper Belt region. Initially, the signal was dismissed as noise, possibly caused by sensor interference or background radiation. However, as more data accumulated and was cross-referenced with international observatories, the existence of a tangible physical entity became irrefutable. What made this discovery so astounding wasn't merely its trajectory or composition, but its behavior. Unlike traditional celestial bodies, which typically follow predictable orbital patterns under gravitational influence, this object exhibited movements inconsistent with known gravitational forces. It slowed down at times, accelerated at others, and even changed direction ever so slightly. Subtle deviations that no naturally occurring object could plausibly exhibit on its own. The scientific community, already alert from previous interstellar visitors like Oumuamua, quickly redirected resources to track and analyze this newcomer. However, this wasn't just another elongated rock tumbling through space. The object emitted a faint but consistent electromagnetic signature, a pattern deviating from the random emissions typical of cosmic debris. It pulsed almost rhythmically, suggesting internal activity or even an artificial structure. Its albedo, the measure of reflectivity, also baffled scientists. The object absorbed an unusual amount of solar radiation while emitting infrared signals in precise bursts, akin to modulated data packets. Such signs strongly hinted at technological sophistication, prompting deeper questions about its origin. What makes this discovery so electrifying is not merely the object's physical nature, but the way it challenges conventional boundaries in astrophysics. For decades, the prevailing assumption has been that any object entering our solar system must be driven purely by the laws of motion and gravity. Yet here was something, perhaps a construct, that appeared to exert its own influence over those laws. Its ability to maneuver at will through space brought a new layer of complexity to the investigation. Not only was this a visitor from beyond the heliopause, but it also seemed to be under some form of intelligent control, or, at the very least, built to respond dynamically to its environment. Michio Kaku, long known for his fascination with advanced civilizations and multiverse theories, approached the phenomenon with the gravity it deserved. He emphasized that humanity might be standing on the threshold of first contact, not necessarily with sentient beings, but perhaps with an artifact, a probe, or an autonomous vehicle sent by an advanced civilization light years away. The implications are staggering. If the object is artificial, it suggests that interstellar exploration is not a dream confined to science fiction, but a potential reality in other parts of the galaxy. If other civilizations can send autonomous technology across interstellar distances, humanity must recalibrate its own aspirations within the cosmic timeline. The object's trajectory has been closely monitored as it continues its journey inward. Its course does not directly intersect with Earth or any major planets, but its path through the solar system seems purposeful, as though following a carefully mapped route. Advanced simulations suggest it will make a close pass by Jupiter's magnetosphere before slingshotting into a higher orbital plane around the Sun. This maneuver, mimicking techniques used by human spacecraft to gain momentum, raises further suspicion that the object was designed rather than formed naturally. Such behavior forces scientists to consider its mission. Is it a passive observer, simply collecting data, or part of a broader, long-term reconnaissance effort? Notably, the object's apparent deceleration as it neared the Sun contradicts the behavior of natural interstellar objects, which typically accelerate due to solar gravity. Instead, this deceleration implies a controlled entry, possibly a braking mechanism, leading to provocative speculation about propulsion. Unlike chemical or nuclear-based systems familiar to Earth technology, this object might employ a form of propulsion entirely unknown to current science. Antimatter engines, quantum drives, or even manipulation of space-time itself are not out of the question. While still hypothetical, the object's presence makes the once fantastical seem suddenly plausible. Astronomers have also noted that the object emits periodic bursts of energy detectable across multiple frequencies, including the radio spectrum. The patterns, though not yet deciphered, seem far too structured to be random. Early theories suggest it could be a self-calibrating device adjusting to the conditions of each planetary sphere it passes, or possibly transmitting data back to its origin point. If the latter is true, then somewhere, perhaps dozens or hundreds of light years away, another civilization could be receiving information about our solar system right now. It may be analyzing our star, measuring planetary atmospheres, or even detecting artificial electromagnetic noise from Earth itself. This introduces profound philosophical and ethical dimensions. Are we being observed? Not in a sensationalized sense, but in the broader context of cosmic exploration. Just as we deploy probes to Mars, Saturn, and the edge of our solar system, perhaps civilizations eons older and technologically superior are studying young planetary systems like ours. Such behavior would align with a non-invasive strategy, a cosmic survey rather than an act of conquest. While we might yearn for direct contact, the message embedded in the arrival of such a probe suggests that patience, caution, and understanding are vital prerequisites for communication. The implications also extend into theoretical physics. The presence of a potentially artificial interstellar object challenges our understanding of the universe's constraints. Traditional theories suggest that the vastness of space and the speed of light pose near insurmountable barriers to interstellar travel. However, if this object hails from another star system and is indeed artificial, those barriers may have already been overcome by another species. This reinvigorates discussions about warp drives, wormholes, and the feasibility of faster-than-light travel. It also reignites conversations around the Kardashev scale, a method of measuring a civilization's technological advancement based on its energy usage. A Type 1 civilization, capable of harnessing planetary energy, is where humanity might reach within a century, but a Type 2 or 3 civilization, with control over stars or galaxies, could plausibly send exploratory vehicles across interstellar distances with ease. Equally compelling is the psychological impact of this discovery on humanity. For centuries, the human mind has occupied a lonely place in the universe, aware of the stars, but disconnected from them in a meaningful way. The idea that we are not alone, even through the passive presence of an alien artifact, redefines humanity's self-perception. Suddenly, we are part of a greater cosmic story. Not the sole protagonist, but one chapter among many. This alters conversations in classrooms, research labs, policy chambers, and religious communities, prompting us to reconsider how we approach life, progress, and unity as a species. The implications for astrobiology are no less significant. If this object is the product of a life-bearing civilization, then life must not only be possible elsewhere, but prevalent enough for civilizations to arise, mature, and reach out across the stars. This changes the Drake equation, which estimates the number of intelligent civilizations in our galaxy. A single confirmed artifact would shift the equation from speculative to empirical, turning the question from if to how many and how far apart. From a technological standpoint, this object becomes a case study, a Rosetta Stone of engineering prowess. Scientists and engineers are already devising mission concepts to intercept it using high-speed propulsion and autonomous AI-driven probes. If a rendezvous could be achieved, the benefits would be immeasurable. Detailed analysis of its material composition, structure, and functionality could advance human science by centuries in a single moment, akin to a Stone Age society stumbling upon a satellite from orbit. An encounter with knowledge so advanced it verges on transformative. At the same time, governments and space agencies worldwide are treading carefully. The global community understands the delicacy of this event, with the potential for misinterpretation or overreaction. There is a growing consensus that this moment must be guided by transparency, international collaboration, and ethical stewardship. If we are being observed, our reaction is likely being noted as well. In that sense, this moment becomes not just a scientific event, but a test of humanity's maturity. All of this has unfolded in an incredibly short time span. Within months, a quiet anomaly became a central focus of global attention, forcing a reevaluation of space policy, international cooperation, and scientific inquiry. The object continues its path through the solar system, and with every kilometer it travels, the questions multiply. Who sent it? Why? What does it know? And perhaps most importantly, what will happen next? But the narrative remains focused on the here and now. The object is still with us, moving deliberately through the planetary plane. Scientists continue to scan its emissions, attempting to decode the patterns in its signals. Mathematicians model its trajectory, searching for hidden variables in its navigation. Engineers brainstorm interception missions, hoping to one day meet it face to face. Amid all this, the public watches with awe, curiosity, and a growing sense of shared destiny. This moment, brought to light through Michio Kaku's revelation, is more than a scientific milestone. It is a mirror reflecting humanity's place in the cosmos, a quiet confirmation that the universe may be more populated, more interconnected, and more mysterious than we ever dared imagine. It is a story still unfolding, one whose pages are being written by physics, possibility, and the boundless curiosity that defines what it means to be human. As the object continued its journey through the solar system, more layers of mystery began to surface. The initial excitement gave way to intense scrutiny, and researchers across every discipline dove into the specifics of its behavior. What was once a distant anomaly became the most scrutinized object in space, surpassing even Mars missions and lunar studies in priority. Data streams from the James Webb Space Telescope, the Solar and Heliospheric Observatory, and deep space radio arrays were funneled into collaborative databases, transforming the effort into one of the most unified scientific pursuits in human history. One of the most surprising developments was the object's interaction with solar radiation. Unlike typical celestial bodies that passively receive solar energy, this object appeared to absorb and redistribute solar photons in a manner that defied standard thermodynamics. Rather than simply warming under the sun's rays and releasing infrared heat, it stored energy in a way that suggested advanced materials or technology, possibly even energy harvesting capabilities. This discovery opened new avenues of thought regarding solar manipulation, triggering discussions about photonic energy storage and real-time reconfiguration of external material surfaces. Scientists theorized that the outer hull could consist of metamaterials capable of dynamically responding to radiation intensity, particle bombardment, and magnetic field strength. As it passed beyond the orbit of Mars, high-resolution images captured a more detailed silhouette. The object's shape was perplexing. It wasn't spherical, cylindrical, or irregular like most asteroids. Instead, it exhibited an angular, almost crystalline structure. The symmetry and edges implied intentional design. Its structure seemed modular, segmented into repeating panels that subtly shifted orientation depending on the direction and intensity of solar winds. This movement wasn't mechanical in the traditional sense, but more akin to a biological reflex. Smooth, calculated, and always oriented toward optimization. The possibility that the object was not just a machine, but a hybrid of technology and biological engineering gained traction. This organic mechanical hypothesis sent shockwaves through the astrobiological community. If the object was partially biological or bioengineered, it meant its creators had surpassed a major evolutionary milestone, the ability to seamlessly merge life with technology. For humans, such an achievement remains speculative, theorized only in advanced discussions about synthetic biology and transhumanism. But here was an example, possibly millions of years ahead of human capability, effortlessly demonstrating what future life forms might become. It also raised questions about the object's resilience and autonomy. Could it self-heal? Was it evolving as it traveled, responding to its cosmic environment in real time? At the core of these discussions was a growing consensus that the object might not be a probe in the traditional sense, but a form of artificial intelligence, perhaps even sentient. Not necessarily sentient in the way humans define consciousness, but operating under parameters so advanced that its decision-making resembled free will. Machine learning models on Earth struggle with basic situational adaptability, yet this object seemed capable of making navigational and environmental decisions without visible input or external control. It was as if it had a purpose beyond mere observation. Was it seeking something, mapping regions of interest, or executing a mission program thousands or millions of years ago? Amid all this, linguists, coders, and AI researchers focused on the object's signal emissions. If this was an intelligent machine or artifact, there had to be a way to understand its communication, or at least determine whether it was communication at all. Using neural networks and comparative frequency analysis, teams identified consistent structures in the object's electromagnetic bursts. Over time, patterns emerged, not in the content, but in the format. The bursts followed recursive cycles, with intervals matching known mathematical constants. The golden ratio, pi, the Fibonacci sequence. This was not coincidence. It was a signature. Mathematics, the universal language, appeared to be the method of choice for broadcasting a message, perhaps not directly to Earth, but as an indicator of intelligence for any sufficiently advanced observer. Still, there was no indication that the object was aware of humanity specifically. It never altered its trajectory to approach Earth, never beamed signals directly toward our planet, and never made maneuvers suggesting direct interest in our presence. This detached behavior led to fascinating speculation. Was it programmed to avoid contact? Or was Earth simply not significant enough to merit direct observation? Perhaps the object was part of a broader network of explorers, each silently scanning stellar systems, only initiating contact with worlds showing signs of higher development, stability, or advanced cooperation. If so, our current state, still grappling with global challenges and only just stepping into interplanetary exploration, might be considered early stage from its perspective. Parallel to the scientific and technological investigations, cultural reverberations swept across the globe. Art, literature, music, and philosophy exploded with renewed fervor. The object, still unnamed by a global standard, took on mythological status. Some called it the messenger, others the witness, and still others simply the eye. These interpretations reflected humanity's psychological need to relate to what it couldn't control or fully understand. In this object, people projected hope, curiosity, and wonder. Scholars found echoes in historical narratives. Futurists saw it as a catalyst for accelerating human progress, and skeptics urged restraint and empirical rigor. In classrooms worldwide, students began asking questions that hadn't been common before. What is our place in the universe? Are we alone? Could we build something like that one day? The object became a symbol of possibility. curricula shifted subtly toward renewed interest in astronomy, physics, and engineering. For extension of the first time in decades, space wasn't just a distant arena for government agencies. It became personal, communal, and deeply human. Meanwhile, geopolitical landscapes shifted in response to the object's presence. Space agencies that had long operated in competition found themselves drawn toward collaboration. Missions to study the object were too costly and complex for a single nation. Even historically, rival nations opened dialogues on joint monitoring efforts. The object's presence became a catalyst for terrestrial diplomacy, uniting countries under the shared pursuit of knowledge. For once, the adversary wasn't each other, it was ignorance. This changed the tone of global discourse in subtle but important ways. Scientific journals, no longer siloed by field, began producing interdisciplinary analyses. Physicists collaborated with biologists. Mathematicians worked with artists and philosophers to interpret data through lenses beyond pure logic. This convergence of disciplines mirrored the complexity of the object itself, something that couldn't be classified into a single category. It was a spacecraft, yes, but also an art piece, a data node, a sensor platform, a potential envoy, and a technological marvel all at once. Its ambiguity forced humanity to expand its frameworks, considering that intelligence and purpose might not always look as expected. One question dominating late-stage discussions was, where did it come from? Efforts to backtrack its trajectory using astrometric data suggested it originated from a region near the constellation Lyra, the same direction as the famous WOW signal, an unexplained narrowband radio signal detected in 1977. Though no direct link could be established, the coincidence was intriguing. That area of space includes several star systems with potentially habitable exoplanets. Could the object have come from one of them? Or was it merely passing through that sector before heading toward our system? More ambitious theories proposed that the object was a remnant of an ancient galactic civilization, predating our solar system's formation. Some hypothesized it could be a form of galactic archaeology, a relic wandering the galaxy, gathering data about civilizations long extinct, preserving fragments of lost knowledge in its core. Such ideas pushed science fiction into the realm of theoretical possibility. If it were truly that ancient, its endurance alone would suggest materials and construction far beyond our current comprehension. In the final stages of its solar journey, the object performed one more unexpected maneuver. It altered its velocity and shifted course, setting itself on a trajectory to exit the solar system at a steeper inclination than it entered. This could not be explained by gravitational interactions alone. It used some form of controlled propulsion, silent and invisible, bypassing all known emissions of thrust or reaction mass. This final act left observers stunned. It was not drifting or falling, it was moving with purpose. Speculation emerged that the object had completed its task. It had scanned, analyzed, and recorded what it needed. Perhaps it had detected specific conditions in the solar system and was returning home. Or maybe it was relaying its findings to another waiting probe farther out. Either way, the message was clear. Its mission, whatever it was, had a defined conclusion. The lack of a direct signal to Earth reinforced the idea that its mission did not include contact, but instead observation, analysis, and silent withdrawal. As it began to fade from visual range, replaced by echoes in radio and infrared, a global awareness remained. The object had not made contact, hovered above cities, or spoken in mathematical languages. But its presence stirred something profound. It suggested that we are not the only architects in this cosmic expanse. Somewhere out there, others build, explore, and observe. This realization changes not just how we look at the stars, but how we look at each other. Every generation has its awakening, a moment that forces a leap in understanding, imagination, and identity. This object, whether a scout, messenger, relic, or autonomous entity, delivered that awakening. It didn't need to speak to change everything. Its existence was the message. Even as it sails into the great void beyond our solar boundaries, it leaves behind a new chapter, one still unwritten, but already alive in the minds of scientists, dreamers, students, and civilizations yet to come. The stars have always held secrets. Now, one of those secrets has passed through our skies, and nothing will ever be the same again. As the enigmatic object exited the gravitational grip of our solar system, its legacy became a central pillar of scientific thought and human culture. The data gathered during its transit was so vast and multifaceted that it would take decades to fully process. Every particle interaction, electromagnetic fluctuation, and minute alteration in its vector provided more than just technical insights. They offered windows into realms of possibility far beyond current human capabilities. Researchers began segmenting the data into specialized clusters: energy management, material science, environmental adaptability, propulsion modeling, and behavioral analysis. These clusters became the core of new academic disciplines, each focused on interpreting the visitor's legacy. One of the most exciting frontiers that emerged was the study of non-human technological aesthetics. For the first time, humanity had a reference point for design outside its own evolution. Engineers and theorists examined the object's geometry and configuration, not just for function, but for the principles underlying its creation. Its structure didn't follow the linear, rigid paradigms of human design, but blended form and function with a sort of elegance, perhaps a form of mathematical artistry or an entirely different aesthetic philosophy. This inspired a wave of experimental technologies aimed at mimicking its elegance. New spacecraft prototypes took on smoother, more organic shapes. Satellite designs incorporated variable geometry surfaces, and even architecture on Earth began exploring structures that mirrored cosmic harmony and adaptive balance. Within this new psychological terrain, societies reevaluated long-standing narratives and origin stories. The question of intelligent design took on new dimensions. Some scholars argued that the presence of such an advanced artifact didn't validate specific belief systems, but breathed new life into humanity's sense of wonder before the unknown. Others contended it was the beginning of a secular transcendence, a reminder that intelligence, wherever it originates, can build, explore, and endure through reason and innovation. These